now we're going to move atoms. So we're going to do three things. The first thing is just translate atoms in the X direction. Then we're going to add the possibility for users to undo their action, and then we will add some randomness. Okay, so I exit SAMSON, and I'm going to code this shake atoms function. So the way for SAMSON elements to access everything related to SAMSON, the data graph, the nodes, the atoms, the bonds, is through the SAMSON interface. So I include SAMSON HPP, and now I'm going to be able to collect atoms in the document, in the active document. So the very important class to collect things in SAMSON is called a node indexer. You can think of a node indexer as an intelligent vector that is combined to a hash table to assign indices to objects. So you can create a node indexer like this. So let's call it atom indexer. And then I'm going to go through SAMSON to collect, to fill this atom indexer. So I get the active document, and then I get all the nodes inside the atom indexer which correspond to a specific query. So in the SDK we have a very powerful system of predicates, node predicates, that can be used to perform searches on the data graph. So here I'm going to select nodes by type. So I'm going to say SB node is type SB node atom. Okay, so this is going to put inside the atom indexer all the nodes for which this predicate will be true. So the node which have a type atom. Okay, and then I'm going to do something with these atoms. Okay, so the first thing we're going to do, just to test that the function was actually called, is to modify the status bar to say hello. Okay, hello, we have n atoms. So let's say SAMSON set status message. We need a string, qstring, so we're going to build a string from a number. So let's say qstring hello, we found number. So we need the size of the atom indexer. Okay, I think there is one parenthesis missing. No, what's going on? 2, 3, 4, 3, 2, 3. Okay. I need the message time, so I want it to be unlimited, so 0. Okay. Let's build the install target. And by the way, since I don't want all the time to go back to the binaries folder and open SAMSON Core, I'm going to configure Visual Studio to automatically call SAMSON Core. Okay, so I right click on the atom shaker here, I hit properties, and in debugging I select the executable. So now whenever I want to execute this target, it will start SAMSON. Let's set it as starter project, and now when I select start debugging or start without debugging, it's going to start SAMSON. So if everything went correctly, it's going to show the number of atoms in the document. So of course you can imagine that if this hasn't worked, I will have redone the video, so you know this is going to work. Let's open a document, let's say this protein here, and then let's see our app, shake atoms, and hello, we found 356 atoms. Okay, so this part worked. We indexed all the atoms in the document, and we displayed the number in the status bar. Okay, so let's exit SAMSON, and now we're actually going to do the translation. So let's do it here. We don't really need this status message anymore, but at least it counts atoms, so it's fine. So we need to loop over all the atoms, get their position, add a certain distance in the x direction, and then set the position of the atom. Okay, so let's do this. In order to iterate over indexers, we have a SAMSON macro SB4 that I use this way: SB node in for all nodes in atom indexer. Okay, so because I want to use functionalities that are specific to atoms, I have to cast my node to an atom type. Okay, so I begin by this. So now I can access the functions of the atom class. The static cast is perfectly fine because I know that I have only collected atoms. Okay, so now I need to find the position. So SB position 3, let's call it position, equal atom get position. Sorry, current atom get position. Okay, so SB position 3 is a three-dimensional vector of length of positions with length units. So we have a very strongly typed system in SAMSON in order to deal with units. So you can read more about this in the developer guide, the fundamentals units, and you will learn about all the units that are in place, how the unit system can be used to do automatic dimensional analysis, etc., etc. Okay, so here the implication is that if I want to modify the position of an atom, I cannot add any float number or double number. Okay, I have to add a specific length. So let's do this. Position v0, the x coordinate, plus equal SB quantity angstrom 1. Okay, so I'm going to add 1 angstrom in the x direction, and then I'm going to set the position of the atom with this new position. Okay, so again we cast in order to access the get position function that not all nodes have. We modify the position. Here we could have say picometer, for example, 100. Okay. the conversion would have been done automatically. And I set the position. Okay, let's install again. And let's run SAMSON. So right now it's not going to shake much, it's just going to translate. Okay, but we have seen several things. We have seen how to access the document, we have seen how to collect nodes, we have seen a bit about predicates and about the unit system. Okay, so I have my interface here. Let's load this protein, and I click on shake atoms, and you see that whenever I press, it's translated by 1 angstrom in the x direction. Okay, so that worked, but it's not undoable. Okay, here if I look at the history, I just have the new document and the add PDB model. So I can go back, but you see that I don't have a history, an action for the translation part. So let's do this. In SAMSON, many functions that modify the data graph are undoable, and normally it should be specified in the documentation. So if we want to make it possible for the user to undo an action, we just have to activate the undo system. And we do this like this: SAMSON begin holding. So to store all the incremental modifications that are going to be made to the data graph, and we give the name of the action that the user will see in the history window. So let's say shake atoms. I know right now it's translation, but later it will be shaken. And here I finish by SAMSON and holding. Okay, I build again. I start SAMSON. Now what's going to happen is that since in this loop I only call some functions which are undoable, like the set position function is undoable. Precisely, it means that if this set position function is between begin holding and end holding statements, then it will create one action that will be undoable by the user. Okay, so let's go back to SAMSON. I open the protein, and I click on my interface, shake atoms, and now you see that whenever I press, there is one more action in the history. Okay, I can go back. Okay, so as much as possible, when you design an app, you should try to make it undoable. Very often it's just a matter of using begin holding and end holding, as long as you're calling functions that are undoable in the SDK. Okay, so one final thing that I want to do is add some randomness to the shaking before concluding this part of the tutorial. So in the SDK there is an implementation of a Mersenne twister, which is the class SBRandom. Okay. Thanks to this class, I can generate random numbers, random vectors, etc., etc. So again, you can go see the documentation of SBRandom, and I'm going to declare it here. Let's say SBRandom random generator, and let's say that I'm going to multiply this distance by a random number. Okay, so what's going on here is that you can do your own dimensional analysis. This is dimensionless, this is a length, so it's fine to add it to a length. Okay, so I'm going to do this for x, y, and z. Okay, I build again. Oh, but this is only positive, so I'm going to make it possible to have also negative values. Okay, so let's start SAMSON a final time for this video. Again, in summary, what this function does is it declares an indexer, gathers all the atoms in the document, displays a status message, turns the undo system on, randomly perturbs all the atoms' positions, and turns the undo system off. Okay. Okay, so here we can see something interesting. Because the random generator always uses the same seed, the displacement is always the same, and that's why the atoms are not really randomly shaken. Okay, so in order to change this behavior, we're going to say that we initialize the random generator with a random value that will be based on the current time. Okay, so for debugging it's good to have always the same seed, but when you know that your function works, you can use random seed. Okay, so I build, I start SAMSON. So let me tell you what we're going to do next. In the next video, we're going to make it customizable, the maximum distance of the random perturbation, and we're going to save this value in settings that will be memorized, so that when a user exits SAMSON and comes back to it, the value will be memorized. Okay, one yrf, the app, and when I shake, it's more random. Okay, but of course it's still completely undoable. Okay, thanks for watching, see you in the next video.